So last section we talked about what systems of linear equations are. Now we are going to solve systems of linear equations by graphing. The beautiful thing is these are all in slope-intercept form. All of this should sound familiar. We've been graphing lines in slope-intercept form since the beginning of the second quarter. So here I have lines, the first equation is highlighted in green. I need to identify two numbers in each of these equations. One is my slope, which is the coefficient of x. The other is my y-intercept, which is the constant. I plot the y-intercept on the y-axis, and then from there, I use my slope, rise over run, so I go down 5 because it's a negative 5, and then I go to the right 3 because it's a positive 3 in the denominator. And now I need to do the same thing with the line highlighted in blue. I've identified both the coefficient of x, which is my slope, and the y-intercept, which is the constant. So negative 3, I plot that point, rise over run, up 1, to the right 3. There's where my two lines intersect, and that is going to be my solution to this system, which is 3, negative 2. Okay, I'm going to do the same thing with the next line here. Label my slope and my y-intercept. Those are the only two numbers we need to identify. Plot the y-intercept, and then slope, since it's a negative 1, I go down 1 to the right 4. In this case, I can do the opposite because I have room. Instead of down to the right, I go up and to the left. Plot those points. Identify the slope and the y-intercept in my blue highlighted line. Plot the y-intercept. Rise 5, run 4. There's where the two lines intersect, giving me the coordinate 4, 2 as my solution. All right, here, again, I need to identify my slope as negative 4. I'm going to put negative 4 over 1. My y-intercept of 3, so I start at 3 on the y-axis. From here, I go down 4, and then to the right 1. I can do that again, since I have room, just to make my dots all in a line. Now with the blue highlighted line here, don't worry about that little smidge. There's no number in front of x. When there's no coefficient of x, you should know that number is going to be 1. I'm going to put 1 over 1 with a y-intercept of negative 2. So negative 2, I use my slope, rise over run, up 1 to the right 1. Since they intersect, I don't need to make any more points. That gives me the coordinate 1, negative 1 as my solution. With my green line here, my slope and my y-intercept are going to be a little bit different. So when there is no x in the equation, we need to draw a line that will not touch the x-axis because there is no x. So on the y-axis, y equals negative 1, so I need to go to negative 1 on the y-axis. So I know my y-intercept is negative 1, but I don't need to worry about my slope because my line's not going to touch the x-axis because there's no x in the equation. The only line that does not touch the x-axis is this horizontal line right there. Now I can identify my slope and my y-intercept for the second line. So at 4, then my slope is negative 5, run 2, a positive 2. So there's where both of my lines intersect. That tells me that's my solution. That is the coordinate 2, negative 1. So something similar here, only now in my top equation, there is no y, which means this line is never going to touch the y-axis. So at negative 2 on my x-axis, because it's x equals negative 2, I put a dot. The only line that goes through that point that will never touch the y-axis is this vertical line right there. For my blue highlighted equation, however, I see a negative sign in front of my x, so my slope is going to be negative 1 over 1, and my y-intercept is going to be a positive 1. And as I go down 1 to the right 1, I see I'm getting further away from the green line. So I'm going to stop, and I'm going to do everything opposite. So instead of going down and to the right, I'm also going to go up and to the left. And that's getting me closer to the other line. So I'm going to repeat these steps from the previous dot up and to the left, and I see that these two lines intersect at the coordinate -2, +3. Remember, your x always comes first, y always comes second in an ordered pair. So here, my top equation, my slope is -2/1. My y-intercept is a +2. Down 2 to the right one, down 2. I like to make as many points as I can in this first line, and then up 2 into the left one, because these points are where I'm going to get a solution. For the second equation, I get -2/1, and my y-intercept this time is -2. Down 2 to the right one. I can do the opposite of down and to the right, up and to the left. And I see that they never intersect. When my lines never intersect, so here I have parallel lines. If they do not intersect, that means I have no solution. So let's identify the numbers we need to here. My slope of the top equation is -1/3 with the y-intercept of 3. So y-intercept is 3, down 1 to the right 3. Do the opposite as well, up 1 to the left 3. Remember, make as many points on that first equation as you can, because those points are where our solutions are going to be. -1/3 for my slope on the bottom with a y-intercept of -3. And I see that these lines do not intersect as well. And when the lines do not intersect, that means I have no solution. So I'm going to identify my slope here as -1/1, because the coefficient of x is -1. Y-intercept is -2. There's my slope. I'm going to make as many points the other direction as well. There's my first line. Now my blue line takes some work here because y is not isolated. I've got to divide everything by -2 to get y all by itself. 2 divided by -2 is -1, x. 4 divided by -2 is -2. So my slope is going to be -1/1. My y-intercept is going to be -2. And if you look, it is the exact same line. When we graph one line on top of the other, we have infinite many solutions. You might also see this symbol right here. That also stands for infinitely many solutions. So here we are going to graph. I have a slope of -3/1. My y-intercept is 7. Before I even graph that, I'm going to look at the next line. -3/1, y-intercept of 7. If you look at these numbers, you'll see that they are the exact same. That means this is the exact same line. One line on top of it means infinitely many solutions. That infinite symbol right there. And that is how we solve systems of linear equations by graphing.